The overall goal of this combinational approach of solid-state and solution-based chemistry is to synthesize novel materials with intrinsic semiconducting properties.
This method can help answer key questions in the inorganic and materials chemistry field, such as how to synthesize compounds not accessible via traditional synthetic methods, or access compounds with uncommon oxidation states, coordination modes, or ligands.
The main advantage of this technique is that it is high-yielding and provides access to reactive pure metallate anion solutions to be used as precursors or for further reactivity studies.
Though this method can provide insight into the chemistry of metallite compounds of the heaviest D10 metal atoms, it can also be applied to other metallites. Generally, individuals new to this method will struggle because all manipulations have to be performed under strict exclusion of air, moisture and in some cases light.
To prepare the dry solvents for synthesis, first add 1 liter of freshly purchased 1,2-diaminoethane to 25 grams of calcium hydride. Heat the mixture under reflux until hydrogen is no longer generated. Then distill the mixture under ambient pressure. Add 1 liter of tetrahydrofuran, THF, to 10 grams of sodium-potassium alloy. Heat the mixture under reflux for at least 12 hours. Then distill the mixture at ambient pressure. Make a saturated solution of Wilkinson's catalyst by adding 20 milliliters of THF to 300 milligrams of the catalyst. After stirring overnight at room temperature,